Hi, everyone, again. This is the third session of the building systems titled Lighting Systems and Mechanical Systems. We're going to have Professor Sermin Onaygil, Energy Planning and Management Division, President of Turkish National Committee on Illumination from Istanbul Technical University, and also Dr. Mustafa Berker, Yurtseven from Istanbul Technical University Engineering Institute and Assistant Director. A short introduction of Sermin Onaygil. She had her master's in energy engineering in 1983, as well as her doctoral degree from Istanbul Technical University, Energy Planning and Management, Smart Building Systems, Energy Economy, General Illumination System, Road and Tunnel Illumination, Illumination Automation, and Illumination Efficiency are her main specialties. She is the founder of National Committee on Illumination, and she represents Turkey in Chapter 4 of the International Committee on Illumination, and she has active roles as the deputy chair. She works as an academic member at Istanbul Technical University, serving as the chair of Energy Planning and Management Division. She also contributes to energy efficiency projects with active roles as arranged by the Ministry of Energy and Natural Resources, as well as providing consulting services to TEDAŞ in terms of road illumination. She is also deputy chair in the board of management of ELR. Now she's going to have her presentation, Lighting Systems. Now the floor is yours, Professor. Great introduction. Thank you very much. And actually, in such an interactive environment, Berker kept nodding. Saying that he agrees with all. Well, you referred to many aspects in your introduction. Hopefully, our young colleagues will also be benefiting from our actually activities. It's great that we can set an example. Turkey needs specialization in many aspects. Thank you very much for this academic session. I've been listening to the sessions starting with the early morning, and technical high school teachers are also with us, right? And when I look at other participants, I see that we need general information. If we don't have a good infrastructure, the superstructure cannot be that strong and cannot actually make a huge success. We have very high themes like zero energy here, but if we do not address infrastructure related aspects, all the costs and R&Ds actually will be weakened. That's why I view this session to be very important from an academic perspective. When you say building systems and create a one-day program, you actually address both easy and difficult aspects of the issue. I will now open my presentation, and we'll be here for actually 115 minutes, 135 minutes. So please actually urge us to speak in clear terms if necessary so that everyone can understand us. Here we'll look at the building's energy efficiency and even its application to the industry, or you may move on to transportation and apply all those things to different vehicle technologies. In all these dimensions, we need multifaceted approaches and experts. And here, technical expertise is not enough. We have social, economic, and other dimensions of this issue. When you conduct a survey in a particular area, you have to collaborate with a specialist in that area. Otherwise, you may have wrong outcomes. That's why experts from multiple areas need to be collaborate. That will take us to the right path moving forward. we were asked to explain the building systems as part of this session. You listen to Professor Hatice from the Energy Institute. We have Professor Berker with us. As Energy Institute of Istanbul Technical University, we have actually different types of specialties so that we can actually cater to the needs of huge scale projects. Illumination and lighting is my main thing. Please ensure that people respect your expertise. I think everyone is referring to lighting or illumination in their speeches. That's fine, as it is a very hot topic. And we probably had impact on this. Now we moved from insulation to electricity engines, illumination, or boiler technology, comfort conditions, automation, smart systems. These are the topics, but we need to fill in. We need to ensure that we work in a dedicated fashion. One expertise area cannot find answers to all these requirements. That's why we are setting an example here. We are meeting here with teachers and audience, and we want to make it an enjoyable session, as all of us has spared some time on Saturday. I said, let me tell about lighting, as I know this topic very well. Okay, I know about other topics too. Can I explain these topics too? Yes, I can, but I should not. My message is clear, right? If we have detailed expertise areas, then we can communicate in a better way and create synergies and sort of reach more qualified projects. I would like to thank the Zero Building team and Yasemin Somuncu, as well as you, dear Gamze, for your contributions to event. I wish a fruitful day to all of our participants. And because we have our participants from the teaching background, we're going to give certain messages. We will maybe give superficial messages. You can fill in, as I told you, by further research. I'm an electrical engineering graduate. Mr. Berker is a mechanical engineer, so he can tell about other aspects concerning electricity area. We have technical vocational schools. We have other schools, so we can have this interdisciplinary approach. Let me try to share my screen and try to understand whether I can take care of it. They asked me to move on to Windows. Can you see it now? I think I can proceed now, right? Yes, Professor, everything is all right. I will be telling you about the lighting systems and energy efficiency there, but I have a 50-minute duration. So I can provide you general knowledge, and we have to move this way. I should start by saying that lighting is a technique, and it's a branch of science which is interdisciplinary. It focuses on the generation, distribution, economy, and measurement of light. So the main element here is the light itself. Radiation, ışınım in Turkish, all have these words. We take this light, we turn it into a concrete form, and then we distribute it. So we should first generate it and assess it with all economic aspects. Let's look at whether we do the right thing. That's why we need to measure it and verify it. That's why it's a concrete branch of science. What does it lead? What else does it lead to? Comfort conditions. Is light a comfort element? Yes, it has its minuses, it has its pluses. So we need to evaluate the necessary situation very well. And it should be focusing on concrete data. Actually, physics engineering lies at the foundation of it. Then we see architectural disciplines, socioeconomic dimensions, and economic approaches. But actually, physics and electricity are intertwined when we talk about lighting. Let's look at these elements too, as they get confused. When we say electricity efficiency in buildings, we refer to natural lighting. Try to get as much natural light as possible inside the building. Okay, but to what extent? Can we have harmful effects like actually burden on thermal loads inside or glares, for example, inside? We need to evaluate all these things. Architectural discipline requires natural element to be used in a way inside the buildings with shutters and other automation systems. When we consider that they are actually included in when they are included in building systems, we talk about the active systems. Here we look at the current system, understand the amount of light taken in. What do we do? Do we write? Do we, for example, have a meeting online, etc.? Are we seated? We actually look at our requirements, and accordingly, we try to create the necessary lighting by looking at the hours where we have natural lighting and where we have lack of it, and also the artificial lighting systems that will compensate for them. That's our goal. And in standards and proposals, actually, the artificial lighting prepositions are made as if there is no lighting, but if we can integrate them well, then that's a good design of the building. Also, we should determine them according to types. I work on roads and tunnels, yes, and I continue to work there and like it very well. Well, they are more challenging lighting forms as you need to calculate much details. However, here we see internal lighting, external lighting, surface lighting, or superficial lighting. If you actually categorize them, we can better understand each other and you can better appreciate the differences. Let's look at the internal lighting. Here we should have flexibility because I make use of this room this way today. I might change it tomorrow, or I'm using here this place as an office. I might use it like a bank tomorrow. So you might need flexible solutions, and energy savings matter, and we discuss it a lot. And here we need to look at the standards and regulations and deliver what is required. Everyone is talking about lighting, but the number of people assessing whether the requirements are met is really low. First, we should actually meet the requirements and then try to save on top of that. They say you should actually compare apples with apples, not pearls. And also, they should be cost efficient with comfort and health aspects. Now, I move on to external lighting, security, criminal crimes are part of it. Energy saving is the second item. Standard and regulations also can be seen there. So, because we're talking about external solutions, easy maintenance is the fourth item. Cost efficient, they should be cost efficient. Energy efficiency should be there. And with smart cities, we need to have adaptive systems for especially road illumination. When we move on to the third category, here we're talking about something dynamic, colorful, and consecutive, repetitive. Here, you should attract people's attention, and the rules of internal and external lighting do not apply here much. We did not include standards and regulations here. If you observe, you need to attract people's attention in the surface illumination. You need to create an effect. You need to beautify the city. You need to contribute to tourism, so you can focus on your goals accordingly. Now we're talking about energy efficiency. Generally, that's where we focus. And you take one source of energy and you make it go through different stages, actually, in these stages, you need to think about an illumination-based approach. You may turn off the light, and you might have savings. That's not what we mean. We mean we will use new technologies and ensure that we will actually focus on social welfare. If tourism is important, then you need to actually eliminate. If security is important, you have to do it. So ensuring energy savings without minimizing those costs is important. Energy savings should be separate from energy efficiency. Energy savings can be deliberate or indeliberate. Here, the users decrease the amount of energy they use or minimize it by themselves. But in energy efficiency, you need new technological means. You should have an awareness. You should also serve a certain goal. There are multiple parameters here. Everyone is talking about energy efficiency as a buzzword, but how is the main question. And here, as I told you, different experts should work together as capable individuals about technology, but also multiple parameters like the economic and social dimensions should be considered. If you have two lights, two bulbs, you can turn off one of them and have savings. But as you see, the switches will, the bulbs will be switched to LED bulbs. When you use this unit with less consumption, technologically speaking, you ensure an energy efficiency. Lighting consumes electricity energy, and here we can say that it is an important parameter in terms of energy efficiency. Generally speaking, in industrial facilities, in a commercial building like shopping centers or hospitals or offices, and even residential buildings, when you make an overall evaluation, you can say that 19 to 20% of 19 to 20% of the electricity energy is used for lighting purposes. But these ratios change depending on the usage area. That's 30% for a shopping center, but it can go up to 60% in hotels or 40% in offices. In homes, it's 10 to 20%, as refrigerators is an important factor as they continuously work in the textile industry. This number goes up to 30%, but in iron and steel industry, it's just 2-3%. So it depends on your usage area, and you need to have a long-term cost analysis before you apply energy efficiency and have a careful, actually, examination of the buildings. So especially commercial buildings, offices, schools, shopping malls, they have to be evaluated in terms of their lighting systems. That's why they are part of the discussion frequently in recent years. And because you decrease the electricity energy consumption, you actually prevent the cost aspect. And here we know that we have to continue our path by decreasing energy energy costs here in all the current buildings. So we differentiate efficiency from savings. Efficiency isn't about turning off the lights. You're not actually compromising on your comfort. When you actually do these lights more than necessary, this may look like great, very actually glaring, but that creates an adaptation problem for people to start with, as other spaces without this many road lighting elements, they will find other areas as dimly light. That's why we should actually have an holistic approach. And we have our national energy action plan. We have certain targets We say we will have savings of 20% until 2023. We have strategies, etc. That's all great, but we should meet the necessary lighting criteria, and we should examine well so that we do not move to a dangerous area. What should we do? First, we will use appropriate light sources. Everyone is on this line. They say, we must deal with it. Let's say we change the chargeable lamp unit. You remove that, let's say, you replace that, but you need to conduct calculations before doing that. I mean, you will not send light up in the air. You need to emit the light to the road surface if you do that. So actually, you need to work with armatures whose values are known. These devices and armatures need to be calculated in terms of savings. We must know the types, varieties. Now we move to savings calculations and to armatures, fixtures, and the necessary limiting the use to the necessary requirements. In offices, we can do certain activities within certain hours. So we need to test the automation systems as we calculate that. If you want to decrease your energy consumption, I didn't want to elaborate on formulas much, but let's elaborate it. This is the watt-hour energy, electricity energy consumption. It's joule divided by second or watt. And here, when you enter a building, you can also check your home or school. You see different armatures in classrooms, different armatures in corridors, teachers in teachers' room, in canteens. So every installation needs to be assessed separately. And that's how we make this calculation. We need to look at the numbers of armatures in every installation, the what amount of energy extracted, and the duration of usage and dimming for these armatures. If you pay attention to all, then you're going to reach the overall amount. Here, I would like to point to this area, which is about power. Actually, our light sources do not work by themselves. They have transmitters, they have drivers, they have ballasts, other elements that work with them. So power should be considered as the total energy taken from the grid. So here we should look at the lowest energy consuming light sources and should use the smallest number of armatures. They have high prices. When you do a cost analysis, the number of armatures as shown by N should be decreased. But in order to do that, you need to have an arrangement. Let's say you have one armature in the ceiling, there's this light in the center, and the other parts are dim. Then one is not enough. You need to have uniformity. Should you have 4 or should you have 8? If there's good light distribution, then you can check it with a well-known photometrics and choose to proceed with 4 armatures. So power is an optimum element, and it is in line with the number of armatures. You need to look at where you need the lighting, on top of the table, in the house, on the road, and here you arrange the time with the automation systems, and you need the appropriate strategy and systems. And here you can see a summary of it. You should follow up on the newest technologies and choose most efficient light sources and other elements, ballasts, transmitters, and here LED is included here. Also, we should ensure that we place the light in high efficiency armatures, and control systems and lighting systems should be working wherever necessary. By the way, Professor Gamze, if you have any questions, please do interrupt me. Sure, Professor, I'm following the questions. I am going at full speed, so please, no, it's going very well. Well, we have to make efficient use of all these sources. Everyone is talking on this layer. Unfortunately, we have to go deeper together with the architecture discipline. Okay, lamp or source light and its auxiliary elements, good electricity circuits, good armature designs you see here in the third step. And then we have to add the automation systems at the end. There are 5 steps. If you are just limited with the first blue rectangular, then we are doing something wrong. Also, I have to refer to the efficiency, not just in terms of the decreases in energy bills. Uh, you are having a conference with many agenda items, and here they're talking about zero buildings, net zero energy. Here, actually, the user is the most important element. When you ensure comfort, actually, you see an increase in efficiency. And that's a huge argument for us in lighting for inside and outside the buildings. By improving lighting, and we see many activities inside the buildings, they say qualified staff works there with well-paid jobs, but the number of sick days or performance evaluation days, site issues, if you consider all of them, for example, in night shifts, a person might have their hands get squeezed in the machine. So all these security arguments all these security issues are strong arguments. So you need to look at the parameters also outside the invoice. It is something very difficult, but we need to have such research activities. And we can do this by checking something before and after. And also you need to have observations and check the performance of a person. So here we use lux as a lighting level. When you increase this, actually the visual performance is enhanced accordingly. People have better vision, but when this performance is increases like that, an easy job in a difficult job, for example, and as in an assembly job where a person works with little parts is more difficult, and you need definitely higher illumination. It depends on the job carried out. It also depends on the age. If someone age 20 sees with 1 unit, after age 50, the eye muscles, for example, get worsened. And here you need to have actually an increase to compensate for that. So it depends on the job done. It depends on the age. Also, comfort, whether you feel well, you feel bad. What is the parameter here? Exhaustion. For example, night shifts, and they conduct tests, for example, to understand the exam performance under a particular lighting and another type of particular lighting. So visual performance is related to lighting level. If it increases, the number of employees with fatigue actually decreases. That's why lighting is an important parameter for that reason. Also, errors in the automotive industry, where you have the manufacturing of quality products, mistakes matter crucially. Customer satisfaction, quality product, the number of products with a defect, all are actually taken into consideration as lighting parameters. Accidents, you can talk about traffic accidents or occupational accidents. For example, someone due to stroboscopic impact see something turning as static due to lighting issues, or a passenger might actually appear before a vehicle. If you do not have good illumination there, you may cause accidents. Also, diseases are addressed, and COVID-19 is a daily topic. But when we looked at lighting, we would think of visual impairments in the past. However, with UVC bulbs, we know that microbes or other germs can be killed. So there are actually different sets of research concerning that. And it is difficult to sum up everything in a very short period of time. But when you look at building as an individual unit, here you have a building performance regulation, energy performance regulation, which actually started to take shape after 2012. And then we have an architectural design, mechanical installations, lighting systems as a title, as you see in red, and electricity installation and electricity consuming systems is still another title. Electricity vehicles, stairs, elevators are all part of it. But illumination or lighting systems are included in our system with architectural project design, building and facility installation, heating, cooling, also lighting and renewable energy cogeneration, creating a cycle. And here we have a certificate which provides this information, the amount of energy consumed, and its equivalent as CO2 emission. Yeah, they say you can turn off the light and save on energy, but should that be the real mindset? It shouldn't, because in illumination and others there are standards and regulations. Here the values should be the we should have the main priority of actually ensuring that we meet these regulations. We can look at new buildings and current buildings. In the new buildings, we have those in project stage, and here we have computer support. And since 2011, they are evaluated as part of the lighting systems with certain okay and missing points. But in current buildings, we need to look at certain aspects, including projects, and sometimes they are missing. An office building might be might be utilized differently. In one floor, there might be an insurance company. In another floor, there might be a bank. So that's difficult to just look at the projects. We need to have on-site ethical evaluations. You see the lack of figures, and you have issues regarding the updates. So we have to look at data.
All this related to, we need to look at the current system which is present, and then of course based on the climate and the other things that should be taken into account. So when we say installed power, we have to look at the amateur numbers, and also the number of light bulbs and etc. The photographing and other things have to be done in this regard. And we see, for example, in Kadıköy municipality building, it is not in 4 days and 24 hours of work. It is an 18 years old building, and it is 15,000 square meters. There are 293 volumes. They were put into Excel files. And also it looked at what are the current situation, what are the suggested suggestions, and of course they try to have it within proper system harmony. Of course there is the lightning energy, the digital indicator, as we have. It is Lenny in English. So we can say that the AESG is in Turkey, and it is about the installed power, the energy amount, a kilowatt per hour divided by square meter plus the year. What divided by the kilowatt per hour per square meter and year. And as you can see, there are the lighting systems, and with lighting systems, even if they are in standby position, when the automation system there are precise lightnings, they can in standby. We have to take into account exported power as well. It is a right approach, but a shortcoming approach at the same time. Let's say you have 1,000 square meter, how many kilowatt per hour energy that you use, and somebody else did the same with a similar square meter, the conditions of use can be different. Or there could be both classrooms. For example, there is a 500 lux and the other one has the 300 lux. So the 300 lux one is spending less energy. So can we say that this is a performance better? According to the standards, it has to be 500 lux. What is the shortcoming? It is not an adequate indicator. It should be a kilowatt per hour per square meter year. The lux or 100 lux should be taken into account. We're trying to evaluate this, and of course we look at whether these conditions are there. There are many things like the occupational safety, etc. There is a general 15193 energy directive as a reference. There is a light and lightning systems for 12,464. It's a Turkish standard. The first one was the internal, and the second one is for the external lightning. When you look at this, for example, there is the automotive sector. It shows whether there's assembly or there is painting, what is the absolute manufacturing, and it's based on this, and also the color for this, and there are certain remarks. So when we look at this, when you put a large resource source there, there is the lightning power magnitude there, and this is at the level of lightning. It is measured with the lux, and you can get a photo cell and you can take this. But if you see, if you look at it from that angle or this angle, that is different. If it is the frictional or it's a flat surface, that is different. So when you ask what do you see and look at this, there is also the brightness. For example, the critical lightnings. Of course, we look at this and we make a calculation about what we see. But in the building, flux is generally enough. We can say that the lighting divided by lumen can be found. And also, when we look at there is a we can say that 360 nanometers and more. We can see the right hand side is a red alert, and the other one is X-ray. As you see, when we say lighting, between 380 nanometers and 889 nanometers, but there are different wave lengths. And for example, there is a 555. That is the highest one. This is for the daylight thing, and also there is for the buildings. This is only available. Of course, there is like a the curve there. You see the blue ones and the red ones, and there is the if I am the producer of energy efficient light bulb producer. So if there is this is so we can say that I need to give a resource light resource with the with the light and with the yellow and green. This would be an efficient resource, but for as the other in other countries of this spectrum. So when you say blue and red, you see it's under the sunlight, daylight. So there are different types, and if they are lacking, you don't see it as a red, you will see it as a brown actually. So the efficiency and also the perception of color is different. For example, in daylight there are all of them are, and in a distance, light bulb of incandescent, everything is there, good but efficient in fluorescent. And when we look at the LEDs, for example, it's a blue one. So this is the polar colors, cold colors. When you go red and yellow, there are the hot colors. So it is about having this. It affects the color, whether it is red or yellow or hot or cold. So when you go away from the Edison's light bulb, you have to look at this very good. When we say that there's a lightning production, there are two systems. For example, in a fireplace, for example, timber is wood is burned, and here and with the different sectors. For example, discharge numbers. For example, from one to the other, there are the new technologies, the LED blue ones, and now we have the LED power and LED resources. We do not use this in incandescent, and so there are sodium bars as we can use. And of course, that you can have energy 160%. It's about what you're changing this with that. And so we can say the lumen, what is important, the color temperature is important, and the life cycle is important. And you pull some power from the network, but there is the light. You can see it as a watt, and there's efficacy factor with lumen. You should notice when we say lumen, this is about the radiation, the value of radiation that you can see. So we can say beneficial radiation for beneficial lighting. So when lumen divided by watt, it gives you the light. For example, Edison's number is 12 lumen per watt. For example, for LED, it is 150 lumen per watt. So there are many different light bulbs here, and in 2019 and 2020, there are eco design requirements for the classification of the lighting resources, classification of the users, and there are self-limiting studies as like the like refrigerators, like the buildings, the lighting is from A to G, but for A, it has to be more than 210 lumen per hour. So there are other things. This is very difficult to achieve. So in energy efficiency, new technologies are challenged. And when the new technologies are used and when the project is done there, it's not saying that I will use a fluorescent only. You have to look at the lumen per watt, and this is how the energy classification should be there. So we look at the lumen per watt. There is a reverse correlation. I select the highest efficiency one. For example, I'm doing something with a textile industrial shopping mall. For example, a person takes a coat as a green, but it is actually it's confused as brown actually. So when there is the color, of course, Calvin, the color renders the color correlates the temperature system. So if there is the color rendering index for optimum, you have to compensate for compromise the water, and of course uh, uh, we have to look at the correlation, the color resources should be there. When you say I'm putting this for that, you have to look at all the things, and some people like how the other the ones called, for example, the LEDs, no matter what they are cold colors. So this is about the structure, and when you look at the LED, there is the hot and cold. So as Edison's light bulb, we see that there are many good progress in this regard. The Kelvin, there are this is like a reverse. It's like a reverse correlation. It means that the hotter it is, the bluer it is actually. Uh, but it's about the value you use it is. So you can use a good color, hot colors for low ones, and if there's a timber, the wooden and timber materials, it is hot colors are taken, and for teachers, and if they are making some activities of this, we can say that it's more than 4,000 Kelvins, uh, and also there are the human focus lighting. There are automation systems which regulates the color. The child comes, wakes up and comes, and this is hot colors. And when the goes back, there are hotter colors. So we can say that the colors in terms of productivity increase, and in terms of uh, the acceptance of what you do is very important. These are all important arguments. And of course, there is hot and cold colors, and also it's about making the perception of the red ones, green, and blue colors. So indoor lighting, this value changes as 100. 0 and 100, and it is not possible to use below 80, and it is forbidden. However, in an art workshop, even where the sketches are there, it is you have to put it like 95. So the life cycle is important, and of course, as I pointed out, so Berker gave me a bit of time, like 10, 15 minutes in the systems. Should I continue, right? The diodes which cause LED power are, it's like a chip, like a die, and there is since at the beginning of 2000s, there are only LEDs for 2000, since the beginning of 2000s, and there are good powers in this regard, and there are improvements there. It says conductive there, and there are two systems, and in positive and negative, we see two powers, and also there's electrical current that is given there, and also we see at the junction there are some holes here, and when you have this, you see that, and there is it produces a light. It's actually a creating radiation, and also it could be day ones, and we could see that effect. So it should be there, so that it is the ones are looked at, and also we see the heat, and it is a loss, and decreasing that increases efficiency, and it is used with the driver as there is a right current, there is electrical efficiency, and there is a thermal efficiency, and as far as we can see, it has to come up with the power. Of course, when you see that there's a phosphoric layer, it shows the seeable area. In order to give you seeable light, there could be short wave. There is a phosphorus there, and there's an the phosphorus is put in the ultraviolet there. So we see the white color, lightning with this, or like it's the red, blue and green are mixed, and you have the power, but you have to lightning. But generally, it is used in the short wavelength. There is a phosphor, the yellow phosphorus is coated, and when you look at LED, you see that actually in all of these, the use temperature is very important. Efficiency is very important. So when you say you switch to LED, you have to look at studies that you can to evaluate all the factors. But since 2000, the others are there, but the LEDs are replacing the conventional light resources. I have two slides here. It's about the lumen per watt. When you compare all of these, and for example, in incandescent, we see 8022, and in LED 80 to 180. But at the same time, under the normal conditions, for example, here, a fluorescent lamp, there is a 110 lumen per watt. You have to be more careful while putting LED here. For example, the sodium, high pressure sodium, once it is 70 to 150. So since 2000, the companies are working in this regard. There are right specifications with the right implementations and practices and applications. We're trying to continue. There is LED, there is LNs, there is the printed one, the cooler, the driver, the armature. So we can say that this is armature, and we cannot now but make a separation. It has to be, evaluated together, as we cannot make a separation. A chip can have a part of 100 lumen watt, but it can go down to 90 lumen per watt, and it should be 130. So you have to come up the armature, and you have to use the design of 130. So the distribution is very important. The photometry it is called, and for example, there is a direct lightning, but in terms of comfort conditions, the indirect ones could be used, but the direct ones should be used. Of course, control, opening, turning it and turn it off, and there is the motion sensors and the controls, and the integrated systems are there, and these are integrated with the heating and cooling systems. So for example, the radiation is actually increase or decrease your heating or your cooling gains. And of course, within the building management systems, that has to be taken into account, and the lighting becomes a very important element. So it is not easy to do that. That is what I'm trying to say. Sometimes the clear-cut approaches may not be the right approaches. You cannot say that, I put the light bulb, it will, the ROI is 6 months. And so that when you have integrated activities, we are talking about the return of investment is like 3 or 4 years, and it is when you consider it from the performance, you have to have the implementable projects. I'm saying this because, for example, in zero build activities, we are using a technology, and this technology, when selected right in the beginning, of course, there will be a cost. And of course, the return of investment should be taken into account with these parameters. For example, this is an office building that you know very well in Istanbul. It's a 13 stories. It started with offices, then it turned into banks and the insurance offices. So, for example, the armatures changed, so then there needs to be 500 lux, but when you just measure it, it is 200 lux. It is 18-story building, so the 12,000 square meters of land. So we looked at we looked at we looked at the volume. It is used in 3,432 hours. Some of them they just turn off the lamp. They say that they cannot see because of incandescence effect. Therefore, the right armature is not selected. For example, when you look at the system, there are fluorescent light bulbs, and you can go for LED or better lights. And after doing this, actually 200 lux is not enough. It has to be 500 and 550 lux. This is what is offered by the standard. So we will increase it from 200 to 255, 550. This is how we make the savings. Of course, the armature number is a decrease, selecting the good armature. So when we look at electric energy, the saving there is like 50%. And when you have the daylight control system, the saving is more than 60%. However, the return of investment is in 4 years. However, I can tell you that the lighting are the system. You can install the systems which have a return of investment of 3 years. So if it is 6 months, it means that it is not conducted very well. But so 1 to 3 years, there could be good solutions. I'm going through the end of my presentation. Actually, we have some tolerance for questions and answers. Tolerance time. The calculations are very important. The designs are very important. But at the same time, you have to, there should be data of the armatures that you're using. For example, there are sheets and there are the calculation methods. It's like making a project. So it is not, I put it and I take it out. It means that I calculate and I put it there. For example, when you look at this, for example, there are four fluorescent lamps at tubular T6. So this is all used in everywhere. There are 4 armatures at also at 18 watts. However, there is here it's a 33 lumen per watt. I make the calculation. Although my objective is to achieve 120 luxes actually. As I told you, in order to have a 400 lux, we need to look per square meter how many watts that I should spend. It is 2.2 up. We will look at this as a whole just in a minute. And I bought a different armature, and there is a different structure there. This is a luminous 53 lumen per watt. And it is the lux is 513 lux, and it is now the indicator is 2.06. We bought a different armature. We use this, and there are 2 lamps, but it is 120 centimeters. So now it is a 73 lumen per watt. However, there is a 516 lux, and when we look at the indicator, we decrease to 1.5. I buy the new, there's a panel armature, a good one. There is a 106 lumen per watt, and the lux is 514. And now I indicated decrease to 1. And when you look at this as a whole, it is we can go from 2 to 1. Of course, I'm always in the stage of within the concept of 500, but the number of armature numbers decreased and the operational cost decreased. And also when you look at this as a unit cost within this system, armature cost will decrease as well. And of course, it's an important parameter. So the data looked at here is using them, and it's about the objective is to ensure 500 lux, and if it is 500 and 600, there will not be any comparison or benchmarking criteria. So this is my last two slides. As of 2015, there is a new era, started with 2 years, and in 2010, that entered into our lives. I didn't look at LED, but after 2010, we've been working in this LED issue as a technology wise. And there is a LEDification process after 2015. However, there are the intelligent lighting systems that you have to have the control. The new systems should be there, but there should be control. So when you look at this, energy efficiency is important. When there's a control, there should be lighter for sustainability, and above that, for the until 2025, there is human-centric lighting. It's about feeling better, increasing the comfort, increasing the performance of the quality of lighting is changing such a way. The human-centric lighting, it's about the color and the level of the lighting. So you start with the low lightnings, and then actually we are following the daylight, and then we go to cold powers, cold colors, and we can say that this activities are conducted at schools, and we had to do them in the projects that we have. So it's about the biological rhythm of this. COVID is very important. We are working at home, and of course the lighting should be in line with the biological rhythm. So there needs to be a motivating factor. So there needs to be a dynamic lightning, human-centric dynamic lightning should be there. It's the lightning out there, and of course, there are smart cities. The lighting is integrated in the parks and gardens, and in the synchronization of the traffic. These systems are continuing. Automation and LED systems. Maybe 10 years later, I will say a different light technology. Now I say LED. So as we survive, we have to study all of these. And as we can see, it becomes the station, and of course it is used in different sources. We say careful while all of this is conducted. In the steel, the armature here is related in terms of related to it has to cover the values that it has to. Therefore, I'd like to thank you for your attention. I've taken like 7 or 8 more minutes. Thank you.
How shall we close the system? There is no problem. So you can close your presentation and you can see. Yes, now I can see you. There is one question. If I remember correctly, Berker Bey asked a question. The key issue while we are designing, visual aspects are paid attention, but other aspects are not taken into consideration, but enlightening begins with an appropriate designing. So do you exchange views with architects? This is my life. In fact, This is what I usually ask people, because it is easy to say it is wrong, but we need to think about, for example, while we are talking about, this is my specialization, these highways and the roads, etc. Therefore, and we use our knowledge that we gained there and we use it in the specifications. So we need to take it, the space of Turkey, and then I'm one of the specialists who knows all these issues, and I am trying to work with regulations, and I put regulations at the center of my activities, and then we do our best. So there is TS as well, especially project designers or energy efficiency directors. If you are a manager in such projects, you can use these standards as your targets, as your objectives, because we have all these regulations. Are you an architect? I'm an engineer, says Gamze Hanım, because in the discipline of architecture, we see it as red, blue, etc., or yellow and white approach. They need to be integrated into each other. And these disciplines need to work hard. But any project that does not pay attention to this, so these issues are taken into consideration. So we try to be everywhere. I also wonder, this natural lighting is a concept that I heard when I began working. What is the potentiality of this issue in Turkey? Because we do not have so many cases and occasions in Turkey. Of course, there is a natural way of using these issues. Yes, that's correct. There are projects that go beyond our imagine. I lived abroad for a long period, and after I returned to Turkey, I realized that there are unimaginable projects. For example, the outer face of the building is blue glass, but if this is the case, no need to prevent daylight because it naturally prevents daylight. But they still implement some systems on the roof, but we need to know where and how to use these systems, because I'm not helpful if I work alone. I need to work with architects to know the design details. And if we work since the very beginning, then we can exchange views, because it is important. You say there is this daylight, but then if you glare, for example, if there is glare, then it is problem. Disability glare, then this is problematic. And these mechanical systems like heating, cooling, and other air conditioning systems need to be integrated into lighting systems. And it is also related to human-oriented approaches. So if there is automation, you can do everything. And we have made progress in this respect. And I'm talking about this issue for 15 years. So everything is in connection with each other. But the key issue is the strategy and the scenarios. And I think that for road and also inner lighting, these type of bulbs that they are using for the decorative purposes. And these are, I think, some problematic aspects. And we have so many concepts that we are discussing, like the artificial intelligence, automated lighting, etc. But we need to know what do we mean by all these concepts. And we need to learn a lot about all these issues so that we can apply them, so that we can use them in our work, because it might be customized lighting. So my age is different than yours. That means my need differs from your needs. And we have different needs, and these are the details that we need to take into consideration. I think you got my message, right? Thanks a lot. Now I would like to move to Berker Yurtseven. Let me introduce him first. Berker, he will make a presentation about mechanical systems. He graduated from the mechanical engineering from Istanbul University in 2003, and then he began his MA, and then he completed his PhD in the same program in 2019. He works as a professor in the Energy Institute of the Istanbul Technical University. He's working in lighting and also lighting systems, and he is also in the lighting board members. So the floor is yours. Thanks, Gamze Hanım, for your kind invitation. And I would like to thank Yasemin Hanım and all other members of the team who have contributed to the organization of this conference. Let me share my screen first. I think you can see my screen now, right? First of all, I would like to welcome you all to this session. We will talk about the mechanical systems today, as Professor Sermin stated. I will do my best. The history. No need to go back to the beginning of the world, beginning of the universe, but everything is based on our needs. So heating, cooling, or ventilation systems are also related to our needs. And it is about our need for heating. And the discovery of fire is the key issue about 1 million years ago. And at that time, people were living in caves, but still there was the need for heating. And that was the first version of heating. And when we look at the cooling history, the first practice, the first application was the pharaohs in Egypt. As you know, Egypt is a country with high temperature. It is the desert climate, and it is hot during the daytime and it is cold during the nighttime. So they have, for example, they put the stones to some areas to cool them down during the daytime, nighttime, and then they use it during the nighttime within the castles, within the houses and buildings, and that was the solution at that time. And we still use the same mentality, and it's same for the baths, the Roman baths, and they were using fire and then gas, and they transmit this gas. And same for mining activities. In order to provide healthy environment to these people, these mechanical ventilation systems were set up and were established. And Leonardo da Vinci developed the ventilator that worked with water. And the first air conditioning was set up in the parliamentary building in the UK, and the system was simple. There was an ice in front of the ventilator, and while the ventilator was working, the ice was cooling the whole surface, the whole building. In the 19th century, the textile sector used this moisture, and 1895, the American heating and also air conditioning engineers Association, and these William Carriers lived in the late 19th and mid 20th century. He is considered as the father of the air conditioning. And then we had this DuPont in 1930. That is the history of the cooling systems. It is called HVAC system. It is heating, ventilation, air conditioning system, air conditionings. So we can call it air conditioning or cooling systems. That is the abbreviation. We use it HVAC. Why it is important? Because these systems are important for our life, since it occupies 90% of our life. 90% of our life is within the buildings. Of course, there are some exceptional cases for some segments of the society, but that is the majority. And that represents the majority of the society. Of course, each building has a common need, that is cooling and heating purposes. Of course, there might be different locations in a building that needs to be cooled down or to be heated. And costs, as regards to cost, they cost a lot, because 10 to 20% of the houses, and as for the commercial buildings, it is 20 to 50%. It depends on the purpose of the building, and also depends on the density of the use, the level of the use of these systems. Of course, if we use them in an intense way, then we consume a lot. And it is also about our comfort. The comfortable life that we have depends on the systems, and we want to use them. When we look at the bigger picture, we see that the HVAC system produces quality air that we need, or that we wish, let me say. And we use the term conditioning, in fact, and the term conditioning is used very often because we arrange the temperature according to our need. And what do we need? We need to know thermodynamic. In fact, the professor made an extensive presentation in the morning, Professor Yusuf Ali Cengel, I mean. And we also need to know the dynamic of the fluids. We have this water and also heat. And we also have the thermal transfer, and also we know the trans and conductivity. As you know, transmissibility is transferring heat from one place to another, one point to another, or one location to another location. It is important. The dynamic is important because the fluid dynamic is important because they move in ducts or canals, and it is important for us. And we have these building energy systems. We have different parts. It is HVAC, lighting, or different disciplines that can be used. And also we can have the transfer systems, and we can have these designings. Of course, we talk about these gas and also vapor mixture because our environment is surrounded with air. It is important when we talk about the water vapor is important, and also other gas like N2O2 or CO2. And of course, heat is important. We have the Celsius, the temperature, and also we have for example, dew points, and it is important. And when we talk about the wet point, it is important to calculate. And of course, moisture is important. And relative humidity rate is important, and also And specific humidity rate is important as well for us. When we look at the heating systems, we all have a system except for the cities. In the southern part, we need to generate heat. We have boilers, we have stoves, or we have sun. We use the sun to get the energy. As I said, it might be boilers or other parts. And then we distribute it to different buildings, and we use ducts, canals, fans, or pumps to distribute the heat, the energy to the buildings. Then we transfer it to the air. We have radiators, we have convectors or fan coils, fan coil units. And we have also have a system to control it, because when the temperature reaches the degree that we wish, then we need to stop, that we need to control so as to prevent extra heat. And we have valves and also claps, and we can arrange the speed rate of the water, and we can control them. We have boiler, it might be combi boiler or central heating boiler system. You can see, especially in the Mediterranean region and also agency, the solar energy, thermal solar systems. In the 70s, following the crisis, it became very popular. And we know these radiators, it is an old version, old-fashioned system. And in principle, it transfers, or the hot water moves in it. And it radiates, but also it heats the air so that it moves. Whether we have convectors, you see this one, and it has fan coil units in it. You can see the red points. These are usually copper pipes, and there are also aluminum wings, so that it transfers the heat. And so in order to spread the system, we have mechanical systems, we have fans in our systems, and we achieve the heating purposes of the building, and then the water returns to boiler, and then the system begins from the beginning. So we get heat from the building for the cooling systems, and we remove the heat from building and send it to the outside. So we can use it, for example, cold water, and we can circulate cold water there, or we can use convectors. And if we use cold water in this convector, then the cooling purposes will be achieved in this case. Of course, we have some panels, etc. And these are the key principles of cooling and heating systems. And we still need a device to control it. It might be a thermostat, or it might be a valve or clamps to adjust and fix the rate. And we have also ventilation system. We need to get this system and we will discuss all these issues in a detailed way within the scope of the field. And we can use it in a detailed way. And we exhaust to air in the system. Of course, this fresh air, we can use it diffusers with this. And if we need filtration, we will use it. And we will have some controls here.
When these tools should start or stop should be actually determined in all these systems. Also, we have systems for auxiliary systems like the evacuation of gases, and also we can have systems for humidity and taking humidity. Also, we should have energy monitoring and management systems in addition to the evacuation of condensing water, and they are used in dashboards and all other systems, and they allow us to make adjustments. We'll be talking about it in the later parts of the presentation. So HVAC systems, cold and hot water installations, also natural gas systems, and also having fire equipment, security and parking lot systems, lighting, installation, electricity and communication equipment, as well as systems that provide reporting and illumination installations as explained by Professor Sermin, and Wi-Fi, Bluetooth or radio frequency using installations, and also lifts and elevators in huge buildings are part of the mechanical systems. They need to be operated in a smart way, and here you need to collect data, process them, evaluate them, and make the necessary adjustments. When we talk about energy efficient building design, experience from the past matters, and we need a multidisciplinary approach with electrical engineers, mechanical engineers, architects, environmental engineers, and many other engineering branches should come together with architects, including the interior ones. And here we want to benefit from natural resources, the design according to the location of the building as well as its orientation. We should choose efficient systems and devices to the extent allowed by the psychology. This is not limited to their selection. They also need to be operated efficiently, maintained efficiently. If there are energy recovery possibilities, we should usurp them, as well as we should have training and awareness for users as part of this energy efficient building design. And here, I would like to tell you a little about comfort. I know there's a session for that, but the science of ergonomy actually deals with the relationship between humans and environment in terms of efficiency, comfort, and health. At university, our professor, one of our professors, asked what comfort is and made this nice definition. I think comfort, the professor said, is the lack of any problems between human beings and the environment. So be it our residential houses or working places, we should not be sweating, feeling cold due to the external environment, or we should not have any glaring due to light sources, or we should feel that the lighting is conducive for our work. These are all the comfort conditions: humidity, air, internal and external pollution sources, as well as noise, lead to lack of comfort. And actually, lighting is another factor that influences our comfort. So when we work somewhere with our clothes on or at home, we have interaction with the environment. Also, there might be sunlights reaching our body. Also, wind has an impact, cooling impact on us. Humidity causes us to sweat, uh, and that also influences our comfort as well as respiration. So this is actually quite a complex system, and considering that everyone will have different comfort conditions, it's not easy to come up with a one size fits all solution. Why did we refer to the necessity of internal air quality? Well, here you may have contaminants or resources thereof. We can talk about cooking products or uh, chemicals like pastes, volatile chemicals like pastes and other flooring elements, paint. Also, we can think about the respirable or breathable particles, including litter, external air, plants, cigarettes, production facilities, and we may have biological substances like the static water mass and other creatures, or radon and other radionuclides like soil, water, building materials, and also smells like volatile chemicals, and bad odors, including those resulting from cooking or cigarette. In the literature, I encountered two concepts. So the first one is sick building syndrome, and it is generally the sort of disorders that disappear after leaving the building, and mostly with undefined causes like irritation on the skin or other respiratory issues like headache, etc. Other concept is building related illnesses, BRA. Here, Pontiac fever, Legionnaire disease, hypersensitivity, and pneumonia, all impacting human health adversely. So just to wrap up, these BIVAC systems include comfort, safety, and economy dimensions. In comfort, you may have a hot or cold weather, also dry and humid one, as well as polluted and clean air. And we know that people and devices also impact our safety, and all of them are combined in money and energy efficient use of the devices as well as the use of energy itself. Another important topic is about controls. How do we heat and cool our house? We have a thermostat working in the traditional systems. Some of us feel comfortable, some of us feel it's very hot, and some of us still don't consider it enough. It might also be the opposite in the cooling scenario, and they depend on the building systems. If we have air conditioners in our homes, we have a fan adjustment as well as a thermostat or thermoregulator, and we can make actually adjustments. And here we may have certain thermostat valves or other tools, and it is one of the least known control methods actually. When we have a degree on an AC remote control, it might say 22, 23, 25, and I'm talking about static ACs here. Generally, they make it minimal, like 17, so that the AC can send out colder air and we can cool the inside of the room quickly. But thermostat doesn't work that. For example, in a split air conditioner, actually it is an indicator of the temperature. inside that room. If it is 17, then you should turn off. I want to keep it 20. I want to make it 17 AC, continuous work until it's very cold, and then you turn off the AC and send the cold air outside. Actually, thermostat shows us the value we want to achieve. So if 24, 25 is the comfort condition for a person, then the AC should be regulated to 24, 25, so that it can help the device keep that temperature inside your room. Everyone has a different comfort zone, though some people might want to make 25 or 26, but generally it is between 21 to 23. That's how the thermostat works in all the systems. The basic issue is the same in big buildings as well.
Tabii ki her tarafa split klima takmıyoruz çünkü çok efektif, ekonomik olmuyor. Büyük klima santralleri kurup orada üretilen soğuğu ya da işte büyük kazanlardaki sıcağı binaya dağıtmak yolunda gidiyoruz. İşletme ihtiyaçları da farklı. Çünkü binanın farklı bölümlerinin farklı görevleri olabiliyor ve biz onları farklı sıcaklıklarda tutmak, farklı nem koşullarında tutmak istiyor olabiliriz. Bunların hepsinin ayrı ayrı kontrol edilip ona göre uygun hesaplar yapılıp ona göre uygun ekipmanların seçilmesi gerekiyor. Bunun için bina enerji yönetim sistemleri var. Bunları hem ayarlamak hem kontrol etmek hem de gözlemlemek için diyelim. Neleri kontrol ediyoruz aslında? Sulu kuru sistemler desek, su içeren sistemler, hani çok kaba, çok genel anlatıyorum. İşte soğuk su üreteçleri, çiller diyelim. Sıcak su üreticimiz kazan, işte pompalar su basıncını kontrol etmek için, vana akış regülasyonu için. Kuru sistemlerde fanlarımız, filtrelerimiz, klepelerimiz, iklimlendirme ünitelerimiz oluyor diyelim. Ve bunların da hem tesisatın hem mahallenin sıcaklık, nemi, taze hava miktarları, çalışan ekipmanların nasıl çalıştığı, performanslarını takip etmek, hem enerji verimliliği hem enerjinin etkin kullanımı,
energy efficient use and effective use of the energy, so that we can turn off the unnecessary running devices, identify any likely issues in devices by audits, and ensure that we maintain the building for all the individuals. We have heating, and here we have ventilation and conditioning. In heating, we have boilers, radiators, pumps. In ventilation, fans, also claps or valves, and also the other elements, as you see on the third side. We might have actually air-based systems. We can have a central climatic system, and here the circulation can be ensured after they are sent. Also, we might have air and water-based system, or we can just have systems running on water, which depends on your technology and design. Central air conditioning systems, how do they work? They're not very complex. We might have, of course, different iterations in bigger systems, but actually there's this absorption of fresh air from outside, and they're sent through a device. And here you have valves or flaps to adjust the air going through. And then there's this absorption duct here, and they are sent back. However, we use the mixed airs as we want to benefit from the air inside. So we send air on the way back to the system once again to ensure recovery. That's how we use these systems. As for the air handling unit, HAU, in Turkish Klima İklimlendirme Santrali, and these are systems carrying out multiple tasks at the same time. I don't know whether you would remember the one on top, window type air conditioners. They would cut the glass and place it in the middle of the window. They were heavy devices. They would send air inside and also send the hot temperature outside. We have split ACs as we speak today. They have different internal and external units, and they are connected with each other, actually, with a copper pipe. And here the weather is sent through the internal unit, cooled, and in the external unit, we see a condensation, and there's this, let's say, hot weather exhaust there. That's an old picture, but it provides a good view. It's AHU. There's a fan inside the device to activate the air, and there are filters. There are, again, valves or flaps to make adjustments, and there are cooling and heating units. This is, again, another wet plant which I photographed in the past. All the pipes are insulated. It's a good practice example, because when we spend energy, we should prevent the system from losing or giving actually these values. And as Professor Yunus Engel stated, if the heating value increases, the heat transfer increases with transfer and radiation. So when we look at the functions of these units, air conditioning, air heating, air cooling are the purposes. That's the main purpose. A typical HVAC system is like this. I inserted the English phrases as well. If you are curious about them, I will tell in Turkish. Here you have this outdoor air to send it to the interior. Let's say it's a cooling example, and there is this cooling element with some copper pipes, as I stated earlier, and the use of this material is to, of course, ensure that the heat transfer is heightened. Hot or cold water goes and it gets heated or cooled, especially in the cooling moment. The vapor transfer capacity decreases together with lower temperature, and then we evacuate this water through these holes. In heating, there's this heating serpentine like the other one, and here you have hot water circulating, and here the air is heated and sent to the interior. We have such fans to create pressure while circulating the air and sort of apply pressure. There are such pipes. Of course, their design matter in terms of amount and noise aspects. So you need to run good calculations. As for air canals, they send the conditioned air to the interior or used to send the air to the outside. Here it emits noise, and it can actually impact the human comfort as an external factor. There are diffusers with different types and structures, as you see on this picture, and they are placed before the air duct and actually distributed to the interior of the structure. We have flaps or dampers as called here. They can be manually or automatically controlled, opening and closing, or opening it to a particular percentage, and the air flow amount can be determined by them. There are those running on an engine or running manually. Filters also matter as they prevent the contaminants coming from the outside air, and they protect our machines. If they interact with the devices, they may cause certain clogs and cause the pressure to decline. There is this example I wanted to insert. This is a newly installed filter, and this is what we encounter after a while. We need to ensure maintenance and keep them clean, because I think no one would like to sort of intake the air going through the filter on the right. We should also check the air conditioners inside our homes. Maybe some of you opened the device to encounter this picture, especially in the workplaces. I ensure cleaning for these devices. I can easily open the lid of the internal units. If you wash them with a soap and water, you can easily carry out the maintenance. Otherwise, it can appear like the photo on the right-hand side. And this may actually impact the performance of your air conditioning device as well as your power plant. As your plant. So you need to pay attention to filters for that reason. And there are thermostats, there are pressure measuring units. For example, this return damper, which we call klapa in Turkish, is controlled. And here there's these heating return air stat control or humidity control units. So here the working of the devices and the controls inside the structure need to be well maintained, well cared of, so that we can identify the issues beforehand. I wanted to insert these images. Here you see the fans creating pressure for the air to circulate inside, and they're embedded, and filters may be installed with cascades or in a flat structure. Different filters can be used. HEPA filters, Berker filters can be used. Of course, as you thicken the filter device, you may need stronger fans because they are creating resistance towards the flow, especially when they get contaminated. So we need to pay attention to all these as we design them. And we have heating and cooling serpentines in these units. I think that would be my last slide. In addition to what Professor Sermin stated, I'd like to make the following remarks. All the building systems, all our lives are surrounded by sensors. In the past 15 years, we were talking about new technology or efficiency, but now actually we talk about how to process the data, how to handle decision-making mechanisms, how to actually carry out optimizations. In the past, we were learning about statistics, but we're talking about data engineering or data analytics, data analysis. Of course, these are overseen by people from computer backgrounds and people with static backgrounds. We see many concepts like AI gaining traction, and now we have departments different than computer engineering for that. For example, AI and efficiency engineering is a new department at ITÜ at our university now. So these training programs are very popular and young individuals are trying to get a place there in an environment with so many sensors and receivers. Actually, their processing requires a complication capability and computer power, and that's an energy intense area. So here we need to enter the analysis as well as good visualization. So our young colleagues to study mechanical systems should educate themselves about data literacy, data analysis, how to interpret data, and also in terms of coding. I explained all of these in a quick fashion because maybe our professor said I'm going to steal some of your time. That would be all from myself. I'd like to make this announcement. Voluntarily, we have 13th National Illuminating Congress between October 6th and 7th. Our website can be visited. It is called Transformation in Lightning or Illumination. You can join it free of charge, and we're going to have certain surprises. Thank you very much for your attention. Thank you, Professor Berker, for your valuable sharings. Now we have a question. I would like to ask this question, both of you. In majority of commercial buildings, we see conditioning with the mixture of air. This came to the forefront in the height of the pandemic, and there was this emphasis on using fresh air. And 100% fresh air is not becoming more popular. So how are we going to manage this negative relationship between 100% fresh air and energy efficiency? Thank you very much for this good question. I was supposed to refer to it somewhere, but I gained speed during my presentation and omitted. During the pandemic, we refer to the shopping centers where people come together collectively, and 100% fresh air is required there. I did not read a lot of literature about this particular aspect referring to a shopping center or an office where an environment working on mixed air, considering that they will work without a mask, can actually send viral infections, not face-to-face, 100%. That was my, okay, I understand the question. So we're talking about a pandemic which may well lead to fatalities, although this might influence electricity engineering negatively. I think I would sort of move to fresh air methodology to be on the safe side and ignore energy efficiency, because there is not a clear answer about whether it will influence or not influence it badly or in a good way. Well, we can have this interactive discussion. COVID-19 has changed our lives radically in the last 1.5 years, and HVAC systems can have ultraviolet lights as actually assembled, and here we can have disinfection, but it is actually covered commercially speaking. Berker is a colleague, we work together, and he knows about illumination, and he joins the energy efficiency activities as a person from mechanical background, and he also is close to heating and cooling issues, but the technical practices are different in practices, as we stated, I mean, I told you that I should be telling about illumination as I try to keep up with the developments and actually look at the issue from a detailed perspective. So it's not an easy thing to say this would be the right or wrong practice. When you look at the lifelong cost calculations as part of the system, health here matters, right? Because the risks created would lead to certain costs, then you should also include those costs in your calculation. But inserting ultraviolet lights in those plants would require us to check their amount as well. In COVID-19 periods, we see the mutations of the virus, and the things tried in influenza are now taken to this context, but we have actually misconceptions. Sometimes you might say it's better than nothing. I mean, you place your hands or you place your keychains, they place ultraviolet lights to kill the germs there. Well, because it is an indoor, enclosed box, I don't know what is happening. I mean, I don't know the flow rate of the air in that ultraviolet application, the amount of retention of viruses, their resistance to radiation. I mean, how much you expose those viruses, whether you're able to catch them in that keychain practice or not, all need answers. I try to avoid speaking in clear terms. This is a multidisciplinary area, and here, how do they do simulation? How do they calculations here? Through simulations, etc. But we don't know the amount of contraction rate or to what extent. I mean, if a person wears a mask, we don't know what should be the amount of duration before he makes the other person contract that. But I think to be on the safe side, we can make use of clean air.
So is there any scientific activity that approves the efficiency of UV lighting? Do you think that it really works? So it is quite similar to my question, because as Berker would plan to say, yes, it's up to you. There is a YouTube video on social media. She discusses the UV lighting. In fact, this is an issue that we have been following since last year, and there will be a specific session on this issue. There will be colleagues from the international arena to discuss all these issues. So facts that are known and unknown. But there are some issues that we have discussed. What I can say is we continue to work, and as I said earlier, electromagnetic typhoon, the wavelength is important, about 30-20, because this 254 nanometer is the light that we know, and the fluorescent, and unless you cover it, then if you use it in a transparent way, the mercury generates something, and what we know that this 154 nanometer has an impact on skin, eyes, etc. And what we know that particularly COVID-19, it is not 254, but also longer nanometers, and it is the argument that it has an effect, and that's what they are trying to implement here as well. And in order to manufacture them, they use different ventilation techniques because they are different lightning sources. But since we use LEDs, which have blue and purple lights, and with their existing size, whether they can be efficient or not. So all these issues are related to the wavelength in the area that you are applying, and also its time, because it has an energy depending on the wavelength and also the period that it maintains it. If effect, it does not kill the virus. It just deforms, or it just stops the virus from reaching you. So there are some studies here, and I'm one of the referees and the jury members of these type of studies, whether they are used in an appropriate way or not. But as I said, these are the studies that people currently working. These are current topics that we discuss, but the key issue is never directly touch upon UV lights, because WHO says direct contact is dangerous. So even you put these disinfection units, when you put your belongings to these disinfection units, then it is dangerous. So when there is no patient, these rooms need to be disinfected while there is no patient. So we should be careful. We should maintain these issues. I'm talking longer because we have time, and people say, do you think these ultraviolet lights is affecting and or causing cancer? It has not been proven yet, but it is radiation for sure. Or even if you pass through a detector, and when we have X-ray, then we are subjected to this. And even if we use our mobile phones, then we are subjected to this radiation. And when we use mercury, for example, when it is broken, its impact on environment is dangerous and it's serious. This is why we have to be careful. So one of the key advantages of the use of LED is as follows. There is no mercury in it, but still there is radiation. The issue of radiation is so complicated. Medicine is working on this and trying to figure out this. And there are also some other disciplines that are working. And of course, when it is applied to a certain area, the material is deformed. And then there are different aspects, especially for the disease and also microbiology. And we need to be careful so that we can reach clearer conclusions. So in the light of all these facts, I think we are unable to make firm statements. We can talk about these issues. Do you have any other point to add? If not, it's a long session since there was no break. I had some sessions. Of course, we respect our time. We have this time that is allocated to our session. It is an advantage that it is on YouTube. Even though people are unable to join us this session, they can watch us later on YouTube. So our slogan needs to be, let's produce solutions to the issues based on the projects. So one by one. We examine cases one by one. So there is no quick fix recipes. This is the only way to achieve what we want. I hope that we are heading towards this better solution. And thanks for providing this opportunity. Thanks a lot. We have learned a lot from this session, and I would like to thank you all on behalf of the whole team. Let's thank the audience and let me convey their thanks to you. So let's meet in another occasion. Thanks a lot. That is the end of the session. Thanks. And we are waiting. We expect you to see in our Congress on Lightning.